All right, in this section we're going to start to talk about what the slope of a line is. So the slope is basically the steepness of a line. If you think of like a ski slope or walking up a big hill, the slope of a hill. So that's what the slope is. We're going to be talking more about this later, but the mathematical term or letter that stands for slope is a lowercase m. It's basically our vertical rise over our horizontal run. So all of these are basically the same thing. Verticals up and down, left and right. It's the change in y over the change in x. And this is a formula we're going to be using later on. So I will come back to that later. Graphing on a slope, we have to indicate direction as positive or negative. So our positive numbers, and this will make more sense when we calculate the slope using a graph, but our positives go up into the right and our negatives are down into the left, kind of like our coordinate plane. If we start at the origin right here, negative numbers are this way and down, positive are up and to the right. So you can kind of think of it that way. But that'll come into play as well because we have to make sure we indicate our values when we are talking about the slope. Equivalent fractions is another one I'm going to talk about, but this is just a quick overview. A positive number over a positive number is the same as a negative number over a negative number, kind of like a negative divided by a negative equals a positive. And again, this will relate to the directions when we are indicating which way we go on a graph. A negative fraction, the negative, if it's just on the outside, will either have to be associated with the top number or the bottom number, but not both. If it was associated with both, it would be the same as a positive. So that is one thing that we are going to practice quite a bit with indicating, one, if either the top or the bottom is negative, then the whole thing is considered negative. But if both of them are negative, the whole thing is considered positive. The next portion about understanding slopes is the direction at which they go. So if we are moving left to right, if we are going uphill, I like to think, that is a positive slope. We are walking uphill. If we are going downhill from left to right, that indicates a negative slope. So these fractions right here, this would be a positive, this would be a negative. There are two other scenarios as well. We have no slope, which means the slope would equal 0. It's just a horizontal line. And then we have the undefined slope, which would be a vertical line. And this I'll come back to as well when we get into calculating slopes. But basically, if we have 0 divided by any number, it equals 0. And if we have any number divided by 0, we get an error on our calculator. And that's one way you can determine whether the slope is 0, it actually comes out to 0, or the slope comes out as undefined. Okay. So if we have a graph and we are trying to determine the value of this slope, one thing we can recognize about this particular slope is that it does go uphill from left to right. So we know the answer is going to be positive. So depending on how we find our slope, it could have two negative numbers based on our fractions. So we can either have a positive over a positive or a negative over a negative, and you'll see what I mean in a second when we go through that. Okay, so here's how we are going to get the numerical value of this slope using these steps. So the first step is to identify two known points. So a known point would be right at an intersection. So like here's a known point, here's a known point. It wouldn't be in between because that's not on a whole number with a positive or negative. So any type of point that falls on an intersection of two whole numbers is what I mean by a known point. So then we are going to do that first. So I am going to, I'll change this to blue here. I'm actually going to increase this so that we can see it a little bit better. All right, and I'm just going to kind of go about here, and we're going to look points on this line that are at direct intersections. So this one looks like one, and now this is a graph I created, so it's not exact, but we're gonna kind of figure out and see if we have a pattern here. So as I slide up this line, here's another known point. Here is another known point. So you're gonna try to be exact on this. Here's another one. Here's another one as well, and it continues to keep going. You can see it's almost like every two spaces. And here's another one. All right, so This goes on forever, so we can identify infinite amount of known points, but all we really need to do is figure out 2 known points. Now I figured out 1, 2, 3, 4, 5, 6, 7, and you can keep going with that as well, but we only need 2. Okay, so after we figure out 2 known points, and that's how you're going to do it, you just kind of follow along and put dots where you see that intersection take place. Then you're going to count your vertical spaces from one to another. So vertical, remember, is our going up and down. And I'm going to back out on this right now, because now that we have our spaces marked, we can do that. So remember, vertical is our up and down, and that is the number that's going to be on the top of a fraction. So we're gonna represent our slopes as fractions. So our top number is going to be how many spaces we move up and down, and our bottom number is going to be how many spaces we move left and right. And again, we are going to pay attention to whether it's positive or negative based on the direction that we are actually moving from one point to the next. Okay, so you can actually pick any 2 points that are next to each other. And if you pick a point like this point and this point, you would just have to reduce the fraction at the end. So what I'm going to do is go from this point to this point. So you can see if I have to go to this point, and I'm only going to indicate my direction up and down and left and right. From this point, I go up 1, 2 spaces. So my top number of that fraction is going to be a positive 2 because I'm going up 2. And then to get over to that blue dot now, I am going to go to the right 1 space. All right, so on the bottom, I'll use a different color here. So I went over 1 space. So since I went over only 1 space, my bottom number would be 2. So my slope for this line would be 2 over 1, or you could just say 2 in this particular case. All right, let's say I went backwards. I wanted to go from this one to this one. Well, the top number is up and down, so I go down 2. So that would be negative 2 because I'm indicating my direction. And then to get over to that dot, I go to the left 1 space. So that would also be a negative direction. So negative 1. And again, we know that negative 2 divided by negative 1 is going to be a positive. So this would also equal positive 2 as our final answer for our slope. So we can represent it as 2 over 1, 2, negative 2 over negative 1, or again, just 2. All right, so in this case, if we leave it as a fraction, that'll help later on when we actually have to plot and graph those. Okay, so we're going to practice a couple. I have some supplementary notes that we are going to add on to this, and we're going to see how we do on this. So again, step 1, we're going to identify known points. So I'm going to identify them in blue here. So I'm going to just start up here and look to where they meet at intersections exactly. So this is 1, and we only need 2. So as I go up, here's another one. So there's my 2 points. That's all I need to start with. Now I need to count from this point to this point, only using straight lines, either up or down or left and right. So the top number of my fraction is going to be the amount of spaces that I move up, and the bottom number is going to be, or down, I guess I should say, and the bottom number is going to be the amount of spaces that I move left or right. So if I go from this dot up, I'm going to go up how many spaces? 1, 2, 3, 4. So if my top number of that fraction is 4, and it's positive because I went up. Then I can go to the right 1, so it's a positive 1 for my denominator. All right, so my slope for this problem is just that, 4 over 1. Now, for whatever reason, you saw this one right here, and you missed this one, and you went up 4, 5, 6, 7, 8 over 2, that reduces to 4 over 1, or just 4. So it's always best to do the 2 closest to each other, because then you don't have to reduce a fraction, but if you miss one, that's okay as well. All right, so let's try this next one. Again, we're identifying known points. Here's a known point. That one's close, but not quite. No. Still going. Okay, it looks like this one right here. This looks close, but you can see it's not quite on. And I tried to be exact with these to just so you guys can practice plotting these. All right, so now we're going to count from one point to the next. I typically go left to right, so in this case, I'm going to go down and then this way. So I am going to count my spaces down. So I have 1, 2, 3, 4, 5, 6. So I went down 6. That's my number on top of my fraction. And you don't have to draw out these lines. All you need to do is be able to count to that one. And then I am going to get over to this blue dot now here. So how many spaces? 1, 2, 3, 4, 5, 6, 7. And since I went to the right, that's a positive 7. So my slope on this one is negative 6 over 7. Go ahead and pause this and try these next two. All right, so I'm going to identify two known points. So let's see. Here's one known point. And this one right here. All right, I couldn't really, it's not quite, but there's not another one, so this is the one we're going to go with right here. All right, so now I'm going to count my spaces. I go up 1 from this one. So my top number is going to be 1. And then I go to the right, 1, 2, 3, 4, 5. So 1 over 5 is my slope. Over here, again, identify the known points. So this appears to be 1. And this appears to be 1 right here. So now we have to count our spaces, the top numbers. So we go down 1, 2, 3, 4, 5. So we went down 5. So we're going to indicate that it's a negative. And we go over to the right 1. So negative 5 over 1 is our slope. Or this would also be just negative 5. Okay, so that is how you determine or figure out the slope when given a graph. So it's practicing counting left, right, up, down, things of that nature.